In this set of videos, we're going to talk about why smartphone cameras aren't better. Why are we talking about this? Well, partially it's just a cool example of ninja physics in action. In particular, it's an example of going to first principles, digging deeper and deeper into the physics to find out what really limits these things. But it's also of great practical importance. If you're a smartphone manufacturer, the quality of your cameras is a major selling point, so very large amounts of money are invested in improving these cameras. But the physical principles we're going to use here, particularly the wave nature of light and the quantum mechanics of photons, which turn out to be what limits the performance of cell phone cameras, are also of fundamental importance to other sorts of sensors. For example, as an astronomer, I use a rather larger sort of camera on a regular basis. This is me, and this is the telescope, the main mirror of the Gemini North telescope, 8.3 meters across. And the things that limit whether we can observe distant galaxies at the edge of the universe, or first stars, or planets around other stars, is exactly the same physics as what limits the smartphones. It's also fundamental in many other cases. The military are deeply interested in sensors because all tanks, spy planes, drones, etc. have various sensors on board which have to again pick up, scan for threats or targets or whatever it might be. So the military spend very large amounts of money on sensor technology. They're actually far more advanced than the civilians. It's also crucial in like self-driving car. Here's a Google self-driving car, and you'll see the LiDAR system at the top, which says laser beam out, and a sensor to pick up the signal as it comes back. So cameras, sensors of various sorts, are fundamental to all sorts of technologies. Now, what is wrong with current smartphone cameras? Well, here's a picture I took with my smartphone, a Samsung Galaxy S6, of the other end of my office, and it looks a pretty nice picture. It's nice and sharp colours and well lit. But one problem is that when you zoom in, you lose detail. So if you pinch to zoom on that exam paper in the middle here, you can see that you can make it bigger, but you're losing detail. It's very hard to read the words here. Maybe you can just make out what's going on here if you squint hard, but really, what's that say or this say? So this is the question of how much detail you can see. It's known as the angular resolution, how sharp the images are, how much detail you can pick out. And that's one major limitation of smartphone cameras. They can't zoom in very much and still have good detail. The other limitation is low light performance. Here's a picture taken at a Christmas party, which is lit by a light bulb up here. And it's again a reasonable picture, but if you zoom in on this region over here, first of all you can see that, for example, this lady's hair and the background are all just black. You can't pick them apart. You can see this person's very blurred. That's because we had to use a very long exposure time, and that meant that her movement blurred the image. And you can see it's very grainy and blotched out and so on. So it's really not cameras, smartphone cameras, in fact any cameras, are not very good at taking pictures under very low light level conditions. So these are the two things we're going to investigate. Why can't we get sharper images, and why can't we take better pictures under low light conditions?